Hello. By clicking on this video, you have chosen to embark on a journey, a mathematical journey in which you will find, as the end product, the shining gold that is the Fritz John conditions. It's like the pot of gold at the end of the rainbow. You know what I mean? That's what it is. So this problem that we want to solve, that is the pot of gold that I mentioned before, is finding this some kind of vector x star in n-dimensional space of real numbers that minimizes f of x subject to these constraints, these inequality and equality constraints. That's the problem. But there's a hierarchy. And in this hierarchy, the Fritz-John conditions, that's at the top. That's like the gold. The KKT conditions, that's like the silver. And the Lagrange multipliers method, that's like the bronze. So the Fritz-John conditions, they're the most general. KKT conditions, they're a little bit less general. The Lagrange multipliers, they only involve equality constraints. On this journey, not only will... Ooh, my pizza's ready. Not only will you learn, but I will also learn on this journey. But why do I want to learn this? Because I'm doing a PhD in data science stuff that relates to biology, and constrained optimization problems, that's used in machine learning. So I want to understand this so that I can understand what I'm applying and apply it to the best of my abilities. So these KKT conditions, they're used in the derivation of support vector machines. Now, what is a support vector machine? That's like a hyperplane that divides space into separate sections. And by doing this, you classify data points into different categories. That's for classification, but it could also be used for regression too. But that uses the KKT conditions, but there's more. So other applications include PCA. Now, what is PCA? Well, it's an algorithm in which you project data points in n-dimensional space onto any number of orthogonal components or axes or unit vectors. And you want to maximize the variance along these unit vectors. And that gives you the principal components. And you solve this maximization problem with the Lagrange multipliers method. Support vector machines, I already talked about that. Hyperparameter optimization. You're just optimizing some hyperparameters. Constrained optimization in neural networks, that's pretty complex. I don't know much about that. Lasso regression, yeah, it's used in there too. Now I allow you to proceed in your journey, but beware. There are bridge trolls that ask you questions about math, and you have to answer them or else you'll be thrown into the abyss. So watch out. Are you ready for your journey? Then let us begin.